Today's notes are 3.3 quadratic equations, and the goal is to be able to find zeros or solutions of quadratic functions algebraically. So quadratic equations have a term of degree 2. That means they have their highest exponent equal to 2. So for example, in standard form we have ax squared plus bx plus c equals 0. So our highest degree here is 2. So we might have negative 3x squared plus 12x minus 17. This is a quadratic equation. When solving quadratic equations, there could be 0, 1, or 2 solutions. Those are the only options. Solutions on a graph look like the spots where the parabola, the shape is called a parabola. The spots where it hits the x-axis. So in this first graph, there are 2 solutions. In the second graph, you see that this parabola hits in exactly 1 spot, so that's 1 solution. And here, the parabola actually doesn't hit the x-axis at all, so that would be 0 solutions. To solve quadratic equations, perform order of operations in reverse order, backwards. By isolating the x squared term and then finding the square root on each side. Let's take a look at a few examples. So number 1, isolate the x squared term. We're going to add 9 to both sides, so x squared equals 9. Then we take the square root of both sides, so x equals square root of 9 is 3. Now something that's important to keep in mind is that if I were to go back and check 3 as a solution, 3 squared is 9, but it's not the only value that equals 9 when we square it. Actually, a negative 3 also works. And so whenever we take the square root of a perfect square, we always need this symbol plus. It's called the plus or minus symbol. So we'll do number 2. X squared equals 25. To solve for x, we add 25 to both sides. X squared equals 25. Square root both sides. So x equals, square root of 25 is 5. But again, a negative 5 would also make this statement true, so we have to include both the positive and the negative of 5. So that's what it actually means, x equals 5 or negative 5. This plus or minus symbol is just a more efficient way of saying that. Number 3, adding 192 to both sides. So this one has one extra step. So we have 3x squared equals 192. Before you can move to take the square root of both sides, you first have to get the x squared term all by itself by dividing both sides by 3. So x squared would equal 64. And now we can square root both sides. So the square root of 64 is 8, so x equals plus or minus 8. Next up, subtracting 36 from both sides, we get negative x squared equals negative 36. So just divide both sides by that negative 1. So x squared equals positive 36. Square root both sides, and we get x equals plus or minus 6. Number 5, add the 48 to both sides. So we get 3x squared equals 48. And divide by 3, we get x squared equals 16. Square root both sides, we get x equals plus or minus 4. Number 6, subtracting the 25 from both sides, we get x squared equals 0. Now, the square root of 0 is just 0. It doesn't have a sign, positive or negative. So this is a case where you would have exactly one solution. On the back, this is a refresher from what we learned in 3.2 about imaginary numbers. When there are no zeros, okay, so there's no places where that quadratic equation hits the graph when we graph it as a parabola, then we must include imaginary solutions. To do this, we use the number I. So I equals the square root of -1. Super important definition of imaginary numbers right here. So we're going to first subtract 128 from both sides, so we get 2x squared equals -128. Divide both sides by 2, so x squared equals -64. Now when we square root both sides, we learned that if there's a negative underneath a radical, it immediately comes out as an I out here. So x equals plus or minus, simplifying 64, well that's nice because it's a perfect square, so that's just going to be 8i. Next one we're going to add the 81 to both sides. Negative x squared equals 81. So divide both sides by the -1 to get the x squared by itself. And we get x squared equals -81. Square root both sides. Negative comes out as an I. So x equals plus or minus, 81 is a perfect square, we're going to write the 9 first. 9i. Irrational solutions. If a solution is not a perfect square, we need to give either exact or approximate answers. So an exact answer is in the form of a radical. So there'll be a radical expression. So for example, we could write an answer as 3 radical 5. And the solution would always be plus or minus. An approximate answer we're going to write as a decimal, rounded 3 places. So for example, we could write 3 times the square root of 5. You type that into your calculator. 3 times the square root of 5, and you get 1.24, it says 57, so I'm going to round that to 6 for 3 decimal places. So this is called an approximate answer. So it's just important to know the difference. If it says exact answer, you do need to leave it as a radical expression. So number 9, if we add 22 to both sides, x squared equals 22. Square root both sides. So we could leave this as x equals plus or minus radical 22. If we tried to simplify this radical, we actually can't. It doesn't, there are no perfect square factors of 22. So then in your calculator, you could write square root of 22, and that's 4.6904. So we're going to write that as plus or minus 4.690. Number 11, adding 8 to both sides, we get 1/3 x squared equals 8. Now don't forget to get rid of this 1/3. We multiply both sides by 3. So that's x squared equals 24. Square root both sides. We could write this as a simplified radical. 4 goes into 24. That's a perfect square, so we could write this as 4 radical 4 radical 6, which is going to be 2 radical 6. So we could say x equals plus or minus 2 radical 6. Or we could write the square root of 24 in your calculator. 4.8989, so that's going to be 4.899. So we could say here's what I should be writing. I apologize. We should change this. The symbol for approximately is an equal sign that's got a curve to it. So we should be using that symbol whenever we are writing an approximated answer. So you could say x is approximately 4.899. Let's see, I'll do one more. I'll do number 14. Add 12 to both sides. So 2/3 x squared equals 12. To get x squared by itself, we multiply both sides by the reciprocal. In other words, the same thing as dividing both sides by 2/3 would be to multiply by 3/2. So x squared equals, it's always nice to leave it as a fraction, then you can kind of reduce it. So 2 and 12 have a GCF of 2, dividing both by 2. So then we are left with x squared equals 18. Square root both sides, we get x equals plus or minus. I know 18 has a root of a perfect square factor of 9, so it's going to be radical 9 radical 2, which simplifies to 3 radical 2. And then again, we could write the approximated answer. Square root of 18 is 4.2426, so x is approximately 4.243. And so that is our lesson on 3.3 quadratic equations.